Bayes theorem. In this module, you will learn about Bayes theorem. Recall that if A and B are two events associated with the sample space of a random experiment, the conditional probability of event A, given that B has occurred, is probability of A and B upon probability of B, provided probability of B is not equal to 0. This further indicates that probability of A and B is equal to probability of event B into probability of event A, given that B has occurred. This is called multiplication rule of probability. Now suppose we have two bags, bag 1 and bag 2. Bag 1 contains 4 yellow and 5 green balls, and bag 2 contains 8 yellow and 3 green balls. We need to draw one ball at random from one of the bags. To draw a ball, first we choose any one of the two bags. If we name the event of selecting bag 1 as A, then the event of selecting bag 2 is not A or A complement. The probability of selecting each bag is half. Now, if we are given that a yellow ball has been drawn, what is the probability that it has been drawn from bag 1? Here, we need to think further. Let us name the event of drawing a yellow ball Y and that of drawing a green ball G. We need to find the conditional probability of A when Y has already occurred. Now, if bag 1 has been chosen, then the probability that the ball drawn is yellow is equal to 4 upon 9, whereas the probability that the ball drawn is green is equal to 5 upon 9. In contrast, if bag 2 has been chosen, then the probability that the ball drawn is yellow is equal to 8 upon 11, whereas the probability that the ball drawn is green is equal to 3 upon 11. The diagram has 4 different branches. The 4 different branches represent 4 mutually exclusive events, that is, the events cannot occur simultaneously. At the end of these branches, we always multiply across all the probabilities. At the end of the first branch, we get the probability of event A and Y. Similarly, the end of the second branch gives the probability of event A and G. The end of the third and fourth branches give the probabilities of events A complement and Y and A complement and G respectively. The probability of drawing a ball from bag 1, given that the ball is yellow, is probability of A and Y upon probability of Y. The probability of getting the yellow ball is equal to probability of event A and Y plus probability of event A complement and Y. Applying multiplication rule of probability, we get this equation. This equation is called Bayes' theorem. It relates conditional probabilities to their inverses. Now substituting the respective values of the probabilities in this equation, we get the probability of A when Y has already occurred. This is how Bayes' theorem works. In this module you have learned that Bayes' theorem relates conditional probabilities to their inverses. If A1, A2 and so on till AN are mutually exclusive and collectively exhaustive events such that none of them has zero probability, and B is any event whose probability is greater than 0, then probability of A, I, given B has occurred is equal to probability of B given AI has occurred into probability of AI upon summation of probability of B given AJ has occurred into probability of AJ, where J equals 1 to n and I varies from 1 to n.